Hello, my name is Despard, and in this presentation I will be teaching how excitatory and inhibitory neural circuits function. Let's first an example of an excitatory neuron. When the presynaptic cell releases glutamate, which is the main excitatory neurotransmitter, into the synaptic cleft, it binds to the AMPA, which are ionotropic glutamate receptors. When the glutamate binds to the AMPA receptors, sodium cations flood into the postsynaptic cell. If the summation in frequency is great enough, this will trigger an action potential. Assuming an action potential is triggered, the voltage-gated sodium channels will open near the axon hillock, which will propagate an action potential down the axon and to the terminal. Between the myelin sheath and the nodes of Ranvier, voltage-gated sodium-potassium channels will be open to allow the chemical transmission to continue down the axon. Once the action potential reaches the axon terminal, it depolarizes the membrane, which allows voltage-gated calcium channels to open. Calcium is important because it allows the vesicle snares to connect with the target snares. And the vesicle snares are seen right here in the cyan color, and the target snares are attached to the membrane in the dark green color. Calcium also acts with synaptotagmin to help with this binding. When the vesicles fuse to the membrane, they release the neurotransmitters into the synaptic cleft. This will bind the AMPA receptors in cell 3, which could potentially generate an action potential in the third cell here. So now for the inhibitory circuit, and this process starts off similar to the excitatory circuit. This begins with an excitatory neuron transmitting a signal to an inhibitory one. This excitatory cell works the same as in the example above. It releases the main excitatory neurotransmitter glutamate into the synaptic cleft, and it binds to the ionotropic AMPA glutamate receptors on the dendrites of cell 2. Then, sodium channels are open near the axon hillock and in the nodes of Ranvier, just like in the first example. This then opens up calcium channels that, along with synaptotagmin, bind to the V snare and the T snares together, which release the neurotransmitters. This is where the change comes. The vesicles in this cell are filled with GABA rather than glutamate. These then get released into the synaptic cleft, where they bind to GABA-A receptors, which are ionotropic. GABA-A receptors allow for the influx of chloride anions into the soma of cell 3. These chloride anions hyperpolarize the membrane potential of cell 3, which is why this acts as an inhibitory circuit. There is no action potential in cell 3 because the membrane potential becomes more negative, increasing the amount of excitation needed for this cell to reach the threshold and trigger an action potential. That has been my project. Thank you very much for watching.